some of the greatest mathematical minds of all ages, from Pythagoras and Euclid in ancient Greece through to the medieval Italian mathematician Leonardo of Pisa, the Renaissance astronomer Johannes Kepler, to present-day scientific figures such as Oxford physicist Roger Penrose, has spent endless hours over these simple ratios and its properties. But the fascination with the golden ratio is not confined just to mathematicians. It lists all these different types of people. They've all pondered and debated the basis of its ubiquity. That means it's everywhere. Ubiquity, something that's ubiquitous, is all over the place. And appeal. In fact, it's probably fair to say that the golden ratio has inspired thinkers of all disciplines like no other number in the history of mathematics. And now I wonder if you can see why I decided to start here. Okay. Now, just look at this quote for a second. Are your computers there? Opening up? Yep. Open up Excel. Yep.
What are mystics?
Mystics. They're people who are interested in like philosophy and things like that you can't measure, and religious people and those kinds of things. Now, they threw around a few names on there, right? But there's one name in particular which you probably didn't recognize, even though you know exactly who he is. It's this name up here. You're like, Leonardo of Pisa. That's not Da Vinci. It's not Da Vinci. That's Leonardo da Vinci. The reason why you don't recognize him is because he was known by a more common name, namely Fibonacci. That was the name he took on, okay? Now, Fibonacci, right? Here's what I'm doing. I'm taking a dive and I'm swimming it a little bit, okay? Fibonacci has this guy buried in him, right? To illustrate this, what I could do is get you to get a calculator out and then, machine out the numbers and all that kind of thing. But that's a bit boring, and you guys have technology here, so you've got Excel there. Now, hands up, and it's okay if none of you do. How many of you have ever opened up Excel? That's the first question. Okay, so most of you, right? That's fine. Keep your hand up if you've actually used it for something substantial. Yeah? Okay, good. All right, now, keep your hands up if you've actually input any formulas into it. All right, good. So hands down. Let's see how we fare with this. We're going to build the Fibonacci series here. Okay? The Fibonacci series tends to be called F1, F2, F3, and so on. Okay. Now, to do it, here's what we're going to do. The first two numbers in the Fibonacci sequence are defined. Right? They are picked out. Right? And they are the first two numbers, 1 and 1. Right? So there we go. Now, by the way, just for what it's worth, you don't have to start with 1 and 1. You can start with different numbers and you get different series, but that's something you can look up later on. Now, how am I going to build the Fibonacci sequence? What's the rule that makes the Fibonacci sequence? Yep. That's right. If I want the third one, I take the first and second and I add them up. This is not hard to do in Excel. You say equals to start your equation. This is familiar. Right? And then you say, I'll take that cell. You can read the coordinates, right? It's A2. Okay? And then I'm going to add the cell beneath it. Simple. A2 plus A3. Okay? And you get the mind-blowing result of 2. You're like, wow, technology is amazing. Okay. Right, now here's where the magic starts. The great thing about this formula, and if you put your cursor over it, you can see the formula reappear in that top bar. Okay? The magic of the formula is that if I just copy this formula, right? The A2 and the A3, they retain their what I would call their relative meaning, which is add up the one 2 above me and the one 1 above me. Okay, so if I copy that, if you copy it, and you just paste it into the next cell, you get 3. Right? Because if you double click on that 3, right? What it will reveal is, look, see, I'm looking at the previous 2 cells. They're highlighted in the colors there for you. Blue and green are the defaults. Okay. Now that means that what we can do is just generalize. You can copy this formula, or if you like it be fancy, you can drag that little square in the corner. And you can paste it down as many times as you like. I'd like you to go up to about 30. Okay? So when you paste it in, voila, you've got all of these terms. Okay? Now, stay with me. Excel can go much further than that, which is great. Okay? You can go hundreds and hundreds and hundreds. But this will be far enough to illustrate the point. Alright, now, you've got another column over. Okay? In this column, rather than work out terms of the Fibonacci sequence, okay, we're going to work out a ratio. We're going to work out a ratio. whoops, sorry. The ratio I'm interested in is from one Fibonacci number to the next one. From one number to the next. Okay, so how do I work that out? Obviously, this number here, it doesn't have a previous one. So I'm not going to worry about him. Okay, we'll start the next one. Division is with the slash sign. Okay, so if you haven't used that already, you say equals, right? And then you say one number, and I'm going to divide it by the previous one. Okay, so it's just like what you were doing before with addition, but here I've got the slash for division. Okay, and again you press enter and you get the mind-blowing result of 1. Okay. But let's keep going. Okay, now don't do them all at once. Okay, just for the sake of it. I just want you to copy it. You paste it once, you're like, okay, 2. No big deal. You paste it again. Well, you get 3 over 2. 3 over 2. That's my 1.5. Right? Now, when you paste it again, something interesting happens. Right? Something interesting happens. It starts to converge on something. It starts to converge on something quite quickly, too. Now, you've done a few, okay? I want you to go down to that, whatever it was, 30 or something like that, okay? And you go ahead and you paste them in. Okay. Right? So you can copy any one of these cells here in your ratio column, and then just paste it down. Okay. Now you can see this is why I said you can stop at 30. You're like, what? What? What just happened? What just happened? The golden ratio just happened. Now, here's the question for you. And I'm not going to answer it for you. I want you to think about it. Why? Why? Remember I said this is the question you ask to help you think deeply about simple things, okay? It's there. It's not a coincidence. Nothing in maths is a coincidence. So why? Why is it appearing here? Yes?
You know what, but why does it just suddenly change in 7 and 8? Like, and number 8 and 13.
So you're talking about...
Yeah, why is it suddenly 1.6?
You mean why does it go up?
Yeah.
If you have a look, pay careful attention, you will see from one to the next, there's a kind of oscillating thing that happens. Can you see? Look. This one is higher, but then this one is lower, right? And then the next one, do you see what's going on? Right? So, sorry, I should do it this way. This one will be lower, then it goes up, then it goes down, then it goes up again and down, and it's kind of doing this.
Stop, Winston.
It's doing this. There's this kind of behavior. It's oscillating, right? So it does look a bit unusual, but it's homing in. It is homing in inexorably to, in fact, if I were to draw this graph, this number would be 5, okay? Going right the way through. Show me? Yeah, bingo. There you go. In fact, let's do that, shall we? Let's all do it, because that's a great idea. You can take all of these, right? Or you can take quite a few of them, right? And did you go to insert? Line? Yeah.
Oh, okay, that didn't work.
There it goes. Okay. And you can see it homes in really fast, right? And it does that wiggling thing, just like I modeled here. Okay, pretty cool.